This is Honors Algebra 2 Pre-Calculus. We're doing 10.2 in Pre-Calc, which is Parabolae as conics. This is example 4, but it's actually in the textbook on page 709. This is what they call example 2. So if you'd rather follow along in the textbook, you can. Not all of my examples come from the textbook, but occasionally I use one. This one was awfully fun and fractiony, so I just decided I didn't want to deal with it. All right, so first thing we're going to do is take this parabola that's written in the form y equals ax squared plus bx plus c, and we're going to write it in standard conic form, right? So in order to do that, I'm going to have to complete the square, which is good times. So first thing I notice is I am really not down for dealing with all of this fraction stuff, right? Not only am I not enjoying the fractions, but I'm not loving that the leading coefficient in front of the x squared is negative. So what I'm going to do as a very first step, just to make my life a whopping load easier, like a whole lot easier, is I'm going to multiply this entire thing by a negative 2. I picked 2 to get rid of the halves because I didn't want to deal with them, and I picked the negative because I don't love my negative leading coefficient, right? So what ends up happening is I get a negative 2y equals an x squared plus a 2x minus a 1, right? So I'm going to have to go ahead and complete the square on this. Now, there are a few ways that I can do this. I'm basically not going to move anything around. I'm just going to ignore the constant like I would normally do to get my x squared term, right? So ignore the constant. I factor out the leading coefficient, but here that's just a 1, so it doesn't really do much for me, right? Ignore the dog coughing in the background. He's an old man. So I'm going to do that triangle step that we've done before, right? I'm going to take this term and divide the coefficient by 2. It's always a 2 to get a plus 1, which I'm then going to square, which will also be a 1. Now, I had a 1 times a 1, so on the right-hand side of the equation, I added 1, so on the left-hand side, I'm also going to add 1, and that'll keep my equation balanced. So what's going to happen is I'm going to get a negative 2y plus a 1 equals a 1 times the quantity x plus 1 squared, all minus a 1, right? If I go ahead and move this 1 over because I know I want this stuff by itself, I'm going to get negative 2y plus 2 equals a 1 times x plus 1 quantity squared, but I want this to look like a 4p, we don't know what p is, times the quantity y minus k. So I'm going to take out this coefficient of negative 2, right? And I'm actually going to inch it over here and finish this out. So I'm going to go ahead and take out this negative 2, and I'll get a y minus 1 equals a 1 times x plus 1 quantity squared. So if I were to rewrite this in the order that we've been seeing it, which I'll erase and give myself some space for this, right? So if we rewrite this, my answer to 1 is going to be x plus 1 quantity squared equals negative 2 y minus 1. Now, if we align that with what we know these values stand for, right? This is my x minus h quantity squared equals 4p y minus k. So if I were to make a list of the stuff I know that h must be a negative 1 because it's supposed to be x minus h and I have a positive 1. So I know h is a negative 1, I know k is a positive 1, so that means that my vertex is at negative 1 comma 1, right? That's the first piece of information I have. So this is the answer you need for the first part of the question, but you're going to have to put some other pieces together for the rest. Other things I know. I can figure out what p is, right? 4p is apparently a negative 2, so p must be a negative 1/2, right? I know that because this is an x squared, it must open down, right? So since this is an x squared, if you have an x squared and a p that's negative, that must mean that this looks like a frown, right? So now if I put all those pieces together, I can go ahead and figure out where my focus would have to be. So what that means, right, if I have a frown, it means that my directrix is up here, my vertex is right here, and my focus is below it, right? So it must mean that I have to move down 1/2 from the vertex. So if my vertex, right, just to show you where my vertex was, right, my vertex was at negative 1, 1, I must have to move down 1/2 to get my focus, right? So that it looks like this situation, so it bends this way. So it seems to me that my answer to part 2 is that my focus is at negative 1 comma 1 minus 1/2, meaning my answer is negative 1 comma 1/2. That's the coordinate of my focus, right? Inch that up a little bit so you can see it better. So again, negative 1 comma 1/2. But again, to put that together, you're going to have to connect a lot of dots. You're going to have to see that an x squared means that it opens downward or upward. You'll have to put together that the negative p means that it opens left or down. And so that must mean that this is a parabola that opens down. So there's my standard form equation. There's the coordinates of my focus.